Hi, welcome my dear students. And today we are going to discuss the functions chapter, different kinds of functions and the problems and concepts related to that. It is a very important. If we complete this total concepts part, we can do the problematic part in functions. We have some different kinds of functions like, right? All those types of functions we are going to understand like, right? This is what we have here. Now this is what functions. In these functions we have, as I told you, that some different kinds of functions we are having here, of course. So okay, before going to that, we know we have some algebraic functions. Like algebraic functions means, you know that what are they, okay, which are algebraic expressions, like algebraic functions, like, right? They are algebraic expressions. These are the heading we have here, algebraic functions. Suppose, right, we have a polynomial function, number one. Okay, a polynomial function. What do you mean by a polynomial function, right? You know that in algebra, a polynomial, what do you mean by a polynomial? If f of x is equal to, okay, a naught x power n, a1 x power n minus 1 plus a2 x power n minus 2, so on up to an, you have here like this, right? Then, okay, here you know this is a polynomial, right, where the powers n, n minus 1, n minus 2, so on up to, okay, these are all, they are not actually, the powers are non-negative integers. That means they belongs to whole numbers, right? And the coefficients are like a0, a1, a2, so on up to an. They are all real numbers. This is what you call a polynomial function, right? This is what you call it as a polynomial function. There are many examples for this, right? Now we have some examples of polynomial functions. Number one, f of x equal to 2x cube plus 3x square plus 5x plus 7. Here you see the powers are cube 3, 2, x power 1, 7 into x power 0. They are all what? Whole numbers. Therefore it is a function, no doubt in it. Now let us come to the second one. Here x cube plus 3x square plus 5x plus 6. This is what you have here, x cube plus 3x square plus 5 into x power minus 1 plus 6. Here x power minus 1, this is not a, okay, this is a negative integer. Therefore it is not a function like this. This is not a function. X cube plus 5 we can write as 5 into x power 0. Therefore it is a function. And this is nothing but x square plus 5 into x power minus 2. This is not a function, right? Why means, here 5 you have here, 5 is nothing but 5 into x power 0. This is a function. And the 0 we call, okay, this is what you call a constant polynomial, like, because the number 5 we can write as 5 into x power 0. This we can write it as a constant polynomial. And 0 we are having here, 0 we can write as 0 into x power 7 plus 0 into x power 5 plus 0, something like this we can write. That means 0 itself we can call it as a 0 polynomial, and whose degree become not defined. Whose degree become not defined, it is a 0 polynomial, however, right? Fine, these are different kinds of functions we are having here. Based on these expressions, we will have some different types of graphs you are going to have, right? Next we have here a rational function, right? A rational function, let us denote it as something like h of x is equal to f of x by g of x, something like this, and g of x is not equal to 0, like this. H of x is equal to f of x by g of x, such that g of x is not equal to 0, where this both f of x, the numerator, and g of, okay, denominator, both are polynomials, like this. These both are what? Polynomials, right? Such a function, see here, because rational number, you know that it is something in the form of p by q, where p and q are integers, where q is not equal to 0. That is a rational number. Here rational function means it is in the form f of x by g of x. Both f of x and g of x are functions. They are polynomial functions, such that g of x is not equal to 0, where f of x and g of x are polynomials, right? Okay, plenty of examples also we can give for this, of course. Plenty of examples we can give for this. Now see here these examples here, h of x equal to x cube plus 5x square plus 7 by 3x plus 2. This is a write a rational function, because this you can write it in the form of numerator by denominator. Numerator is a polynomial and denominator is also a polynomial. And here also h of x is equal to, this is one polynomial and this is another polynomial. Therefore, this is also a rational functions. Like just numerator and denominator both are polynomials. Any polynomial you take, these are what you call rational functions. Now we have another different type of function is explicit function. What do you mean by explicit function? Means if you have, suppose the function, let us represent f of x is purely in terms of x, that we can represent purely in terms of x. For example, something like x cube plus 5x square plus 6x plus 7. This is purely in terms of x. Such a function you call it as y is equal to f of x. You are able to represent y or f of x purely in terms of x. Such a function you call it as an implicit function. For example, with the examples we will understand very nicely. Okay, for example, we have here f of x is equal to x plus 1. This is purely in terms of x. This is what you call an explicit function. Next, f of x is equal to some x square plus minus 1. This is also an explicit function. You can give plenty of examples. X square minus 5x plus 6. This is also an explicit function. Next, we have here f of x is equal to x cube plus 8. This is also an explicit function. Like this, if you are able to express the function purely in terms of x, you call that as an explicit function, right? Next, we have an implicit function. An implicit function means a function which is in the form if f of x comma y is equal to 0. Okay, the function which involves both the variables which combines the group x and y, like this. Okay, such a function you call it as an implicit function. Like this function involves both the variables x and y, such that this is equation in two variables x and y. Then y is called implicit function of x. For example, with examples we will understand very nicely. For example, we have here x square plus y square plus 3xy plus 3xy square. Okay, plus 3x cube y. Okay, this is equal to f of x comma y. This is what f of x comma y is equal to, we are having like this, right? This is an implicit function. Like that we can do plenty of examples, like something like we have here x power 4y plus y power 4x plus x cube y plus y square x. Like this, many we can. It is a function which involves both the variables, like that. Such a function, what you call it as an implicit function. Such a function, what we call it is an implicit function, right? Fine. Now we have another function. Y is equal to f of x is equal to x square. This is actually f of x. This is an algebraic function, because x square is an algebraic expression. It is an algebraic function, like this, right? That means it is what is domain of this? Domain means any x value we can give for this, of course. Domain is what? Set of all real numbers. What is the range of it? Range means what are the output values you are going to get, right? What are the output values you are going to get means x square, you are having any positive number if you apply. You see here, for example, we have here something like f of 1, that is 1 square, that is 1. F of 2, that is 2 square, that is 4. F of 3, that is 3 square, that is 9. F of minus 1, that is nothing but minus 1 square, that is 1. F of minus 2, that is minus 2 whole square, that is 4. Any negative value if you give also, it turns out to be a positive value. Therefore, the range is nothing but r plus union 0, like this. This is what the range of it. Okay, domain and range is like this. And what about this graph? The graph when you draw like this, right? As I have told you that here, suppose x is 1 here. Okay, here x, f of x. We have here x, and this is what f of x, like this we have here. If x is 1, f of 1 is 1. If x is 2, f of, right, if x is 3, f of 3 is 9. X is, right, and this is minus 1, like f of 1, minus 2, and this is minus 3, f of minus 3, that equal to minus 3 square, that is 9. You have like this, right? And how you will draw the graph is very simple. You are going to get like this. the graph you are going to get. Suppose if you take here 0, 1, 2, 3, 4, so on like this. This is -1, -2, -3, -4. This is from minus infinity to plus infinity. Let us take, because these values are more, let us take something like 2, 4, 6, 8, 10 like this. Here also like this if you take, of course. -2, -4, -6, -8, -10 like this. Right? If you take 0, 0 will be here, and you have here 1, 1, 1, 1, 1 is here like this. 2, 4 is here like this. 3, 9 will be here like this. -1, 1, -2, 4 like this. -3, 9 will be. You just join with a simple freehand. You are going to get like this. Any graph will be drawn like this. This is a upward parabola, actually upward parabola. This is the shape of it, whose domain is nothing but this and range is nothing but like this. How will you draw the graph? Means you take x values and f of x values. Just you will get a point 1, 1, 2, 4, 3, 9, -1, 1, -2, 4, -3, 9. Like this, anything if you take the table of values, you will be joining like this, then you will get the graph of the function like this. Hereafter, whenever I draw a graph, it means that we will take the table of values like this and we will draw. Okay, every time I may not take table of values. You can take some different values of its domain, and you will get. For this example, I am taking the table of values. For the other curves, I am not going to take the table, but it takes a lot of time. I think you give different values of x, you will get different values of y. Now we have point will be formed x, y like this. This is what y. Okay, the point is here now 1, 1, 2, 4, 3, 9, -1, 1 like this. With these points you are going to plot and join with a free hand. You are going to get the curve. Now we have another algebraic function. Y is equal to f of x is equal to x cube. Here by this, what is the domain of this? What is the domain? For every function we have to find out domain and range of it. The domain is nothing but what are the possible input values, x values you can give such that the function will become defined. Okay, that is nothing but set of all real numbers. And the range is also set of all real numbers. Whatever negative values you give also, it will comes out to be negative. Okay, because of odd power. Even if you give positive ones, it will comes out to be positive. If you give negative ones, it will comes out to be negative values. Therefore, range is also real numbers for this function. F of x is equal to x cube. How will be like in the previous way? We are going to take a table of values and we will, if you draw the graph of it, the graph of this x cube will be like this. Okay, it comes, if you take different types of x values here from -infinity to +infinity like that. It comes like this. From -infinity it starts here and it goes like, as x values starting from -infinity, it starts like -infinity. As x values reach towards +infinity, it will reach towards +infinity like this. This is what the graph of y is equal to x cube, and domain is real numbers and the range is also real numbers, right? Next we have another different function, constant function. A constant function, it is something like f of x is equal to some constant, where k is a constant that may be a real number here, of course. Right? What is the domain of this here? For this domain of this function, you see, domain is nothing but set of all real numbers. Any real number you give, okay, it will give the output as that particular constant only, right? And range is nothing but, what is range? Whatever input value you give, the output value. Range means the output value. That is nothing but the element k itself like this. Okay, we have the element k itself. For example, here if you take here, for example, if you take f of x is equal, for example, if you take y is equal to f of x is equal to 5. If you take f of 1, that is 5 only. F of 2 if you take, that is 5 only. F of 3 if you take, that will be 5 only. F of 4 if you take, that is 5 only. Any input value you give, you are going to get the output value as 5 itself, like this, right, my dear students? That's why the range is nothing but set, here the range is nothing but 5 only. And the graph of this function, we have got domain and range, next the graph of it, of course. For example, here we take here 0, 1, 2, 3, 4, 5, so on like this. And here this is minus 1, minus 2, minus 3, so on, this minus infinity to plus infinity like this. We have here, okay, 1, 2, 3, 4, 5, 6 like this. Here for this function y is equal to 5. If you take 0, this is also 5. Even f of 0 is also 5. 0, comma 5, this is the point. 1, comma 5, this is the point. 2, comma 5, this is the point. 3, comma 5, this is the point. 4, comma 5, this is the point. 5. Okay, anything, minus 1, 5. Like this, you are going to get a line by joining this. You are going to get a line which is parallel to x-axis. This is the graph of the constant function, and it is the definition, domain, and range is like this. We have next we have identity function. Generally, identity function is denoted by I. I of x is equal to x for all x belongs to R. That means whatever input value you give, the same thing you are going to get as output value. That means even otherwise you can write even f of x equal to x also. Just it is a symbol difference. For all x belongs to R like this. Therefore, here the beauty of this is nothing but whatever input value you give, the same thing you are going to get the output value. Therefore, you see here this function, what we have, the identity function. What will be the domain of this? Okay, domain is nothing but all real numbers you can give. Once okay, the domain is all real numbers, range output values also the same real numbers you are going to get like this. Output values also will get the same real numbers. If you take the graph of it also here, of course, it's very simple. You know that x, f of x like this. F of x is equal to x like this. Right? If you take 1, it will give 1. If you do 2, 2, 3, 3, 0, 0, 4, 4, 5, 5, minus 1 like this. It gives you. Therefore, the graph is like thing but is like a straight line. You are going to get 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. Here, okay, 1, 2, 3, 4. Here, minus 1, minus 2, minus 3, minus 4. 0, comma 0, 1, comma 1, 2, comma 2, 3, comma 3, like this. 4, comma 4. And minus 1, comma minus 1, minus 2, comma minus 2. If you join just like this, right, you are going to get a straight line like this, of course, right? This is what the graph of y is equal to f of x is equal to x. Generally, it is denoted by I of x. This is what an identity function, right? Now we have the function, some rational function 1 by x like this. Okay, 1 by x. F of x equal to 1 by x. And what is domain of this? So domain means since it is we have here 1 by x in the denominator. X cannot be 0, then other, okay, 1 by 0 become undefined. That's why we have to take out that 0. Domain is nothing but R minus of 0 like this. Set of all real numbers minus 0 is what the domain, because you have to take out 0 like that. And the range what you are going to get, of course, right? Okay, the range once you have taken this the range what you are going to get, the range is also here except 0. Okay, you cannot get 0. You are going to get all the real numbers, R minus 0. Therefore, this is a function something like R minus 0 to R minus 0. You cannot get here 0 like this. Okay, and the graph of this, as I told you that if you take table of values and if you observe, the graph is going to be something like this. If you take something like here 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Here 1, 2, 3, 4. Now minus 1, minus 2, minus 3, minus 4 we have here. This is from minus infinity to plus infinity. Here also from minus infinity to plus infinity we have here like this. Once you have these things, the graph of it is like this, right? And okay, fine. And this will be like this. This is what the graph of 1 by x. If you take the values, and at 0 it is not defined, you see here. At remaining values, at 0 it leads towards here minus infinity, here it goes towards plus infinity like this. At remaining values it is perfectly defined, and this is what the graph of the rational function 1 by x. Now see another function, okay, y is equal to f of x equal to 1 by x square. Y is equal to f of x is equal to 1 by x square. Like previous one is 1 by x. Here x square, which is in the denominator, which is nothing but a perfect square, and it will give you all positive values, of course. Of course, now here domain, if you think of this, of course, domain is equal to r minus 0, like this. Okay, because x cannot be 0. If x is 0, 1 by 0 become undefined, and output means I told it should get finite values. R minus 0 is what the domain. And the range, okay, the range here, there is no possibility of getting negative numbers, of course. There is no possibility of getting negative numbers, right? That's why the range is nothing but, of course, even it cannot take 0, of course, because if you equate 0, you cannot take 0. Therefore, set of all positive real numbers is what? Okay, the range is nothing but set of all positive real numbers, that is from 0 to infinity, like this. And the graph, of course, it will be looks like this, of course. Okay, 1 by x square, we know x square graph, and this will be something like this. Okay, if you have 1 by x square, you have here, it starts here, okay, from but it will never touch 0, it will comes and moves towards infinity, and here also it however comes and moves towards infinity, like this. This is what the graph of y is equal to f of x is equal to 1 by x square. Y is equal to f of x is equal to 1 by x square is this is the graph of it, and domain and range is this. This is the nature of this function. Now we have some irrational functions. So those are y is equal to f of x is equal to root x, right? This is an irrational function, okay, root x. If you observe this, so let us first find the domain of this. What are the input values you can give for this? This is what x value, x is the input value. Okay, the domain of this is, you know that x cannot be negative, x can be 0. That means, you know, x can be greater than or equal to 0. That means, you know that this is actually r plus union 0, like this. This is nothing but, of course, okay, 0 to infinity, like this. Closed interval 0 to infinity. This is what the domain of this. And the range, okay, the range, what are the output values it is going to give you is the output values whenever you give. See, once the positive values it gives out the values also, right? R plus union 0, the output values. This is what closed interval 0 to infinity. Once if you got this thing like this, now you have here minus infinity to plus infinity, and this is now minus infinity to plus infinity, like this, right? We have here 0, 1, 2, 3, like this, and the graph, because it takes only input values as positive values, the graph is going to be like this. When you give 0, 0, 1 means 1, 2 means root 2, 3 means root 3, like this. Right, this it will rises the graph. This is the graph of y is equal to f of x equal to root x. And how you will draw, as I told you, you can take table of values and you can observe the shape will be like this. It is actually above the x-axis, means it gives always the positive values, whose output values also. That's why the range is 0 to infinity, and the domain also 0 to infinity. We have got like this, right? Now we have another function y is equal to f of x, x power 1 by 3, that is cubed root of x. Okay, cubed root of x. So here the domain, since it is cubed root of x, the domain we can give any real number, because cubed root of minus 2 is defined, cubed root of minus 3 is defined, cubed root of minus 1, that is minus 1 only. Like that it is defined. You can give any real number. Once the domain is any real number, the range is now, the range is also is equal to any real numbers. Because once you give all real numbers as the input, you will get the output as all real numbers. The range is nothing but all real numbers we are going to get, like this. Okay, wonderful. And the graph is, as you see that the graph of this function, okay, as you give, this is 0, negative, minus infinity to plus infinity. If you give negative numbers also, it is giving the negative numbers. That's why the graph will be like this. The graph will be like this towards the negative x-axis. Towards the positive x-axis, it will be like this, of course, right? This is what the graph of y is equal to, see here, f of x, that is equal to x power 1 by 3. This is the graph whose domain and range is real numbers. Next we have here these piecewise defined functions. That means modulus function. This is something like y is equal to f of x is equal to mod x. is the definition of this. How it is defined is mod x is, it becomes you take x, mod x is equal to x if you take if x is greater than 0, and you take 0 if x is equal to 0, and you take minus x if x is less than 0, like this. You take minus x if x is less than 0. You see, for example, here, my dear students, once if you observe, okay, x if I take, for example, f of 5 I want here. F of 5 is modulus of 5. Since 5 is positive, you take as it is, like this. And I want f of 0 because modulus of 0 becomes 0, like this. Now I want f of minus 5, like this. Now, and minus 5 is a negative number, that's why you have to take modulus of minus 5 equal to, they told minus x, that means minus of minus 5, that become 5, like this, right? You are going to get that as plus 5. That's why the output values of this function will be always positive. And well, we come to the point of the domain and range. Domain is nothing but set of all real numbers, and the range is nothing but right, because all positive, because it gives the output as all positive real numbers and including 0. That's why this is 0 to infinity, like this. This is actually r plus union 0, like this, right? Range is this, domain is real numbers and the range is nothing but r plus union 0. Now the graph of this function y is equal to mod x, f of x equal to mod x. It is very simple that, see here, minus infinity to plus infinity, right? Even this x is equal to mod x, okay? This is what f of x, of course. If you give 0, it gives 0. If you give 1, it gives 1. Minus 1, it gives 1. Because modulus of minus 1. Minus 2, this becomes 2. If you give 2, 2. 3, minus 3, 3. 3, it gives 3, like this. Therefore, this one is something like 0 here, 1, you have 2, 3, 4, 5, so on, like this. This is minus 1, minus 2, minus 3, minus 4. Here 1, 2, 3, 4, so on, like this. Here 1, minus 2, minus 3, minus 4, so on. This is now minus infinity to plus infinity. Now 0 comma 0 is this. Now 1 comma 1 is here, 2 comma 2 is here, 3 comma 3 will be here, minus 1 comma 1 will be here, minus 2 comma 2 will be here, minus 3 comma 3. It is, if you just join like this, you are going to get a V-shaped curve like this. This is the graph of this, and we have discussed domain and range of this function already, right? You know, now we have an interesting function called greatest integer function or step function, like this, or step function, like this, right, my dear students? How this greatest integer function or step function? This is defined as f of x is equal to, this is the symbol, okay? And what is the definition of this is set of all integers, okay? This is set of all integers, right? How it is defined is set of all integers lesser than or equal to x and greatest among them, like lesser than or equal to x and greatest among them, like this. Greatest among them, like this. This is what you call the greatest integer function of x or step x, like this. Set of all integers lesser than or equal to x and greatest among them is what the right. Now let us try to understand this. For example, if I have f of 2.7, this is nothing but okay, greatest integer function of 2.7. How we will be getting this is all integers lesser than or equal to 2.7. That means minus infinity, so on, up to minus 3, minus 2, minus 1, 0, 1, 2. They are all lesser than or equal to 2.7. And the greatest among them is what? 2. Therefore, the value of this, okay, greatest integer function of this is nothing but 2. We have here as 2, like this. Now in the same way, f of 2.8, this is also greatest integer function of 2.8 is nothing but 2. In the same way, we are going to have like this. Now I want f of 10.5, like this. Okay, greatest integer function of 10.5 is 10, by this. Same concept, however, all integers lesser than or equal to 10.5 if you take. This is something like minus 3, minus 2, minus 1, 0, 1, so on up to, okay, 8, 9, 10 lesser than or equal to 10.5. And the greatest among them is nothing but 10, like that. Greatest among them is 10. That's why its value equal to 10. Now greatest integer function of f of 0, that is 0 is equal to 0 only you are going to get. Of any integer if you take, even f of 5 if you take, greatest integer function of 5 is 5 only, because all integers lesser than or equal to, okay, minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, 5. This is lesser than or equal to 5 is 5 itself, like this. In the same way, if you have f of something like minus 6, that is minus 6, that is now minus 6, like this. And if you have suppose f of minus 2.7, what will it be? Means all integers lesser than or equal to, minus 5, minus 4, minus 3, lesser than or equal to minus 2.7. And the value is nothing but minus 3. This is equal to now minus 3 we have got like this, right? Now we have here f of x equal to step x, okay, fine. Now even you take minus 3.8, these examples, like this value equal to minus 4, and f of minus 3.7, that is also minus 4. F of minus 4 become minus 4 only. F of minus 4.1, this become minus 5, like this. Right, what will be the domain? What we have observed here is the domain of this greatest integer function. Domain of f of x is equal to greatest integer function of x is nothing but set of all real numbers, like this. And the range of f of x, that is greatest integer function of x, is nothing but set of all integers. We observed that all the outputs comes out to be set of all integers. That's why the range is nothing but set of all integers we are getting here. Now the graph of this is going to be like this. We have here this is negative x-axis, minus infinity to plus infinity, right? Now see this graph, when you have greatest integer function of 0 is 0, 0.10, 0.20, 0.30, this is like this. Next 1 will be 1, 1.1 will be 1, 1.2 will be none, 1.9 will be 1, like this. 2 will be 2, like this. 2.1, 2.2, 2.3, 2.9 will be 2, like this. 3, 3.1, 3.2, 3 up to 3.9 it will be 3. Now 4.1, 4.2 up to this. Right, and from also 0 minus 0.1 become minus 1, like this. Like this, it is in the form of steps, like this. You see here, it is in the form of steps. That's why it is named also as a step function. You see here, like this, it is in the form of steps. That's why this is named as a step function, like this. Now we have very important things, the properties of greatest integer function. This is a very important kind. The first one, if you take here, of course, right, you know that the greatest integer function f of x is equal to, this is also we call it as step function, like. And if the values, you see my dear students here, if x lies from 0 to 1, like this, okay, 0 is included but 1 is not included, its value is nothing but what, 1, like this, okay, its value is nothing but not 1, not 0, this, okay. If 1 lesser than or equal to x less than 2, its value, right, between 1 and 2, but 2 is not included here, of course, this value become 1. That means 1.1, 1.2, 1.3, 1.9, like that. Next, 2 lesser than or equal to x less than 3, this value is 2. Next, 3 lesser than or equal to x less than 4, this value is 3. Like that, from minus 1 to, right, you have here minus 1 lesser than or equal to x less than 0, it is minus 1. Next, right, like this, minus 2 lesser than or equal to x less than minus 1, it is minus 2. Next, minus 3, this become minus 3, so on, it will be defined like this. This is the first thing, the definition, how it is defined here, of course. And regarding okay, the domain and range, we have discussed about that. And the third one is nothing but the second one is, suppose you have something like okay, step of x plus k, where k is a constant here. This you can write perfectly, step x plus k, where k belongs to real number. For example, you can observe anything, of course. For example, I have here something like 5.8 plus k, k is some 10, I am having like this. This I can write as step of 5.k plus 10, I can write like this. This is nothing but now what we are going to have, Okay, step of 5.8 plus 10, this is nothing but step of 15.8 like this. And this is nothing but, okay, this value is 15 here, of course. This is now 5 plus 10, that is nothing but 15. This is equal to now 15. We have here 15. This is what the second property we have here like this. Now the third one, right? The third one is what we have here, right? Suppose we have here the third property, step of x, okay, step of minus x is what? Like step of minus x. This becomes minus x if x belongs to integers, like if x belongs to integers, if it is minus x only. And if x is not belongs to integers, if x does not belongs to integers, like this. If x does not belongs to z, then what it will become means this equal to minus of step x minus 1, like this. Minus of step x minus 1. How this is, let us understand it in a very clear way. Okay, with an example we will understand here. Okay, for example, we have here, suppose x is equal to, you take 10, then step of minus 10 is nothing but minus 10 only. Okay. Okay, minus x means minus of 10 only, like that. Suppose you take x equal to, which is not an integer, 10.8 you take here, of course. Now step of minus 10.8 is nothing but you will get minus 11. This is nothing but minus of step x minus 1. That is now minus of step x is nothing but 10.8 minus 1. Minus of step of 10.8 is what? 10. Minus 10 minus 1. That is nothing but now minus 11 you will be getting. Right? Now see the next property we have here, if x belongs to z, step x plus step of minus x equal to 0. And if x does not belongs to z, it become minus 1. For example, we are going to observe this how, let us take x is equal to 5. It is an integer. Therefore, step of 5 plus step of minus 5. That is nothing but, 5 minus 5. That becomes 0. Now this 5 belongs to z. Let us take that x is equal to 5.7, which does not belongs to integers, like this. Now step of 5.7 plus minus 5.7, like this we have here. 5.7 is 5 and step of minus 5.7 is minus 6. That equal to minus 1, like this. This function has this property. Now we have another property. This is step x minus step of minus x. This is equal to 2 times of step x if x belongs to z. Let us take x is equal to some other example, 6. Then step of 6 minus of step of minus 6 is equal to 6 minus of minus 6. This becomes 6 plus 6. This is equal to 12. Like 12 means this is actually 2 times of step x. That is now 2 times of step 6. That is 12, like this. If x is equal to 6.7, like that means it does not belongs to z. This is belongs to z. Now step of 6.7 minus step of minus 6.7, like this. This becomes 6 minus of this is minus 7. Now you have here is equal to 6 plus 7, that equal to 13. This is nothing but 2 times of step x plus 1, like this. This is now 2 of 6.7 plus 1, that is now 2 into 6 plus 1, that equal to 13. In this beautiful way we will be understanding this property. Next we have another sequence of properties, something like step x if it is greater than or equal to k, like if it is greater than or equal to k, that implies x is greater than or equal to k, like this. Right? You can easily observe that, of course. Okay, step x is greater than or equal to k, then x is greater than or equal to k, where k belongs to z, like this. Where k belongs to z, you take k equal to some number, for example 5. Step x is greater than or equal to 5 means, that means x should be greater than or equal to 5. That means x may be, you have something like greater than or equal to 5.7, 5.8, 6, 7, 8, like that. If you take like step of now 6.8 is greater than or equal to 5. That means 6 is greater than or equal to 5. That is true. In this way, you can check the sequence of properties. Now the seventh one also, you have here step of x is, suppose you have here greater than k, then x will be greater than k plus 1, like this. X will be greater than or equal to k plus 1. In this way you will have here, where k belongs to z like this, k belongs to z like this, right? And the eighth one in the same way, step x is lesser than or equal to k like this. Step x is lesser than or equal to k, that means x is less than k plus 1 like this, where k belongs to z like this. And the ninth property you have here, step x is less than k, then step x is less than k, then x is less than k like this, right? Where k belongs to z. Like that we have now the 10th property also. You can easily observe, we will write here because the good amount of space is here. Now step of x plus y, you can easily verify with some examples nicely like this. Step of x plus y, where x and y are real numbers, is equal to step x, right? We have here plus step of, you have y plus x minus step x. You can easily observe, okay, where x comma y belongs to r like this. You can easily verify these all with nice manual numbers, then you can get that. Now we have another one, fractional part of the function. How this is defined as f of x is equal to flower brackets x. This is defined as x minus step x for all x belongs to r real numbers like this. Fractional part of x is equal to x minus step x for all x belongs to r, right? This will give you only the output as fractional part. For example, if you want f of 6.7, that is now fractional point of 6.7 is nothing but 6.7 minus 6.7 like this. This is now 6.7 minus 6. This is now 0.7 like this. Next, fractional part of, suppose minus 6.7 we want. This is minus 6.7, that is nothing but okay, minus 6.7 minus of minus 6.7 like this. Now this is minus 6.7 plus, okay, minus into minus, okay, however this is minus of minus 6.7 is minus 7. Now this is minus 6.7 plus 7, this is equal to 0.3, right? The fractional part of minus 6.7, it comes out to be 0.3. And when we come to this fractional part of the function, what is domain and range? Here the domain, here only they given that it is defined for all real numbers, and the range is nothing but it is going to be 0 will be included, okay, only the proper fraction, 1 will not be there of course. And the graph of this we can easily understand, my dear students. Here this is from minus infinity to plus infinity. We have here 0, 1, 2, 3, 4, 5, 6. Okay, here we have 1. Now 0 to 1, it is going to be like this. 0 to 1 it will be. Now 1.1, 1.2 up to 1.9 it will be like this. 2.1, 2.2 like this. 3.1, 3.23 like this. Okay, if you join all these things, this is the graph of this function. Okay, even for negative numbers also, minus 1, minus 2, minus 3, you are going to get the graph is going to be like this. The graph is going to be like this. 1.1, 1, 1.2, 0.2, 1.3, 0.3, 1.9, 0.9 like this, right? Next we have signum function. This is f of x equal to mod x by x when x is not equal to 0 and is equal to 0 when x equal to 0. This is the definition of this. See, my dear students, here let us define precisely. When x is not equal to 0 means when x is positive integer, then mod x by x is nothing but x by x, that is 1. And when x is less than 0, when x is less than 0, mod x is nothing but minus x by x, that is minus 1. When x equal to 0, this becomes 0. Therefore, this signum function is precisely defined when x is greater than 0. Okay, when x is greater than 0, it becomes 1. Like when x is less than 0, it becomes minus 1. When x is 0, it becomes 0. Therefore, the domain is what here? The domain is nothing but here the domain of f of x is equal to mod x by x is nothing but set of all real numbers. It is defined, and the range, you only now observed that the range is nothing but minus 1, 0, 1 like this. Minus 1, 0, 1. This is what the domain and range of this. Once if you get the graph of this, the graph is going to be like this. We have here minus infinity to plus infinity. Here 0, 1, 2, 3, 4, 5. Here 1, here minus 1. Here also minus 1, minus 2, minus 3, all negative real numbers. For 0 it is defined as 0 here like this. For greater than 0, all these, it is going to be 1 like this. For all negative numbers, it is going to be minus 1. This is the graph of these. Like this, we have these wonderful functions and very knowledge about these functions are required. This will be helpful for us to do the calculus chapter in our further topic. Thank you very much.